Chapter 2. The physical mechanism through which mental healing is effected. Thus far in the history of the scientific investigation of mental therapeutics, attention has been directed almost exclusively to the psychological aspects of the question. This was natural, for the simple reason that mental healing, as its name implies, is primarily a psychological phenomenon, and success in mental healing necessarily depends upon mental conditions. This being recognized, it was inevitable that the attention of scientists should first be directed to an inquiry as to the practical methods of inducing those conditions, and that was naturally thought to be a purely psychological problem. Besides, the light which the new psychology has shed upon that problem is so brilliant and so satisfactory in its practical application to the subject matter that for the time being all other questions have been ignored as subsidiary, if not unimportant. The fact remains that there are some very important questions relating to mental therapeutics that have not yet been adequately considered, questions that reach the very heart of the subject matter, both as to evidential importance and its practical value in the treatment of disease. It is true that mental healing belongs primarily to the domain of psychology, and that without a clear understanding of the fundamental facts of man's psychological makeup, mental medicine would still be and remain in the dismal realms of fable and superstition. But it is also true that the mental power which heals resides within the physical organism which is healed. It follows that if it is true that the bodily functions and conditions are thus controlled, there must exist some evidence of the fact in the bodily structure itself. That is to say, if the mind controls the body, it must do so by means of appropriate mechanism, and, in the absence of such mechanism, science would be compelled to reject all other evidence of mental control of bodily functions. On the other hand, if it can be shown that such mechanism exists, that it is coextensive with the physical organism, and that it is obviously adapted to the uses of conveying intelligence from one part of the body to another, the evidence will be complete that the mind controls the bodily functions. Then, if it is found that there exists a duplex mechanism, the functions, powers, and limitations of which correspond to what is known of those of the dual mental organism, it will constitute indubitable evidence of the scientific validity of our hypothesis of mental duality and presumptive evidence of the soundness of the theory of mental medicine which we have outlined in Part 1. Fortunately, we have not far to look for abundant demonstrative proofs of the existence of mechanism especially adapted to the uses named. We have but to turn to any of the standard works on anatomy and histology, sciences which investigate, respectively, the naked eye and the microscopic structure of the healthy body. And I desire to say, at the outset, that, in dealing with this branch of the subject before us, I shall not travel outside of the recognized paths of science as they have been outlined in the works of standard authorities. It is to histology, or microscopic anatomy, that we must look for the mechanism through which the mind controls the bodily functions in health and disease. Histology, as it is now universally accepted, is a comparatively new science. That is to say, it is based upon facts of comparatively recent discovery. Like all other sciences, however, it is the product of evolutionary development. It may be said to have had its origin in the 17th century through the discovery by Hooke, Malpighi, and Grew. These scientists, making observations with the simple and imperfect microscopes of their day, saw in plants small compartment-like spaces, each surrounded by a distinct wall and filled with air or a liquid. To these the name cell was applied. During the latter part of the 17th and the 18th century, these earlier observations were confirmed and extended in various directions. No substantial advance was made, however, until Robert Brown, 1831, discovered a small body in the cell which is now known as the nucleus. 5 years later, Valentin observed in the nucleus a small body now known as the nucleolus. Schleiden, in 1838, adduced proofs to show that plants were wholly made up of cells and attached special importance to the nuclei of cells. The next discovery was by Schwann, in 1839. It was he who originated the theory that the animal body was built up of cells, resembling those described for plants, and he defined a cell as a small vesicle, surrounded by a firm membrane enclosing a fluid in which floats a nucleus. This conception of the structure of the cell was destined, however, to undergo important modification. In 1846, von Mohl recognized in the cell a semi-fluid, granular substance which he named protoplasm. Other investigators observed animal cells that were devoid of a distinct cell membrane, and Max Schulze, in 1861, attacked vigorously the older conception of the structure of cells, proclaiming the identity of the protoplasm in all forms of life, both plant and animal, and defining the cell as a nucleated mass of protoplasm endowed with the attributes of life. In this sense, the term cell is now generally used. The definition of a cell has been still further modified by the discovery that a nucleus is not essential, for none exists in the cryptogamia and in some of the lowest animal forms. In these exceptional cases, the cell consists of a simple mass of protoplasm. Haeckel, however, does not recognize the lowest forms of animals by the term cells, for cells by no means represent the lowest grade of organic individuality, as that is usually understood. The cytids, for example, are living, independent existences which consist merely of an atom of plasmin, in other words, of an entirely homogeneous atom of albuminous substance, which is not yet differentiated into nucleus and protoplasm, but exercises the properties of both united. For example, the remarkable Monera are cytids of this kind. Strictly speaking, we should say, the elementary organism, or the individual of the first order, occurs in two different grades. The first and lowest is the cytid, which consists of an atom of simple plasmin. The second and higher grade is the cell, which has been differentiated into nucleus and protoplasm. This, however, is a question of terminology which, for present purposes, is unimportant. The fact remains, as Haeckel proceeds to say, that both grades, cytids and cells, are grouped together under the idea of sculptors or builders, because they alone in reality build the organism. That is to say, every living physical organism in this world is built up of cytids and cells, and this is the first salient fact which I desire the reader to bear in mind. Before proceeding to discuss this matter in detail, however, I desire to remind the reader that all living animal organisms are divisible, broadly, into two classes, namely, unicellular organisms and pluricellular organisms. The former, as the term indicates, are one-celled creatures and represent the lowest forms of animal life, the beginning of animal life on this planet, the earliest of man's earthly ancestors. The primordial germs from which all living creatures on this planet have been developed through the processes of organic evolution. The latter are simply aggregations or associations of the former. That is to say, pluricellular organisms are merely confederated associations of unicellular creatures, a later development from unicellular life. The unicellular organism was, and still is, the true terrestrial type of life, for it displays all the functions, in miniature, exhibited by pluricellular creatures, namely, feeling, motion, nutrition, and reproduction, the sum of which constitutes the idea of life. All these properties which the multicellular, highly developed animal possesses appear in each cell, at least in its youth. There is no longer any doubt about this fact, and V/E may therefore regard it as the basis of our physiological idea of the elementary organism, Haeckel. In other words, there is but one type of life on the surface of our planet, and that is the unicellular, and this type is preserved in all the forms of life. The unicellular organisms are termed protozoans. Pluricellular organisms are termed metazoans. It would be highly interesting to follow the phylogenetic development of the cell from the monoran to man, but that is outside the purpose of this book. It must suffice to say that the metazoans were at first simple aggregations of the protozoans, and the fact of aggregation does not seem to have modified the separate unicellular lives, for each retains its complete autonomy, performing all the functions of a separate life. Change of conditions, or mutations of environment, however, led to more permanent grouping and compelled modification and differentiation of functions, until at length it became impossible to dissolve the bond by which the unicellular lives were united. Thus the way was opened for further differentiation of functions, and thenceforth organic evolution proceeded on those lines. That is to say, the moment that an aggregation of cells became a confederation, with its differentiation of cell functions and consequent division of labor. Every further step in advance consisted in increased differentiation of cell functions and still further division of labor. As a result of a long process of such differentiation, the organisms of the larger animals and of man came to be composed, as we find them, of 30 or more different species of cells. For example, we have the muscle cells, whose vital energies are devoted to the office of contraction, or vigorous shortening of length, connective tissue cells, whose office is mainly to produce and conserve a tough fiber for binding together and covering in the organism. Bone cells, whose life work it is to select and collocate salts of lime for the organic framework, levers, and joints, hair, nail, horn. And feather cells, which work in silicates for the protection, defense, and ornamentation of the organism. Gland cells, whose motif in living has come to be the abstraction from the blood of substances which are recombined to produce juices needed to aid the various processes or steps of digestion. Blood cells, which have assumed the laborious function of general carriers, scavengers, and repairers of the organism. Eye, ear, nasal, and palate cells, which have become the special artificers of complicated apparatus for transmitting light, sound, odors, and flavors to the highly sentient brain cells. Pulmonary cells, which elaborate a tissue for the introduction of oxygen and the elimination of carbon dioxide and other waste products. Hepatic, liver, cells, which have, in response to the needs of the organism, descended to the menial office of living on the waste products and converting them into chemical reagents to facilitate digestion. These and numerous other species of cells. And lastly, most important and of greatest interest, brain and nerve cells. These cells are of the greatest interest and importance, for the obvious reason that they are the most highly differentiated of all the cells of the body and constitute, respectively, the organ of objective intelligence and the means of communicating information from one part of the body to another. Without going further into details for the present, it must suffice to say that each organ of the body is composed of a group of cells which are differentiated with special reference to the functions to be performed by that organ. In other words, every function of life is performed by groups of cooperating cells, so that the body as a whole is simply a confederation of the various groups. And, to the end that the body may act as a unit, these groups are connected, each to all the others, by lines of intercommunication, which, in turn, are composed of other highly differentiated and specialized cells, namely, brain and nerve cells. Not only are the various groups thus connected by lines of intercommunication, but these lines reach, directly or indirectly, every individual cell in the whole organism. This is elementary, for everybody knows that when any part of the organism is assailed, information of the fact is instantly conveyed through the nerves to the central office, so to speak. And their measures for protecting the part are as instantaneously devised and the appropriate commands issued. Thus, if one of the extremities is pricked with a needle's point, the cell thus assailed instantaneously conveys information of the assault through the nerves to the brain, which, in turn, issues its edict, through the appropriate nerve cells, to all the muscle and other cells surrounding the injured cell, commanding them to unite their forces and remove the part assailed from the point of danger. This sounds like an elaborate process, requiring considerable time to effect it, but it is just what actually happens when one's great toe is pricked and he jerks it away. It is called reaction, and in a sense it is, but the remedy applied is the result of a series of mental processes, beginning with the message sent to the brain by the injured cell, and ending by the application of the united forces of the muscle cells to the removal of the injured cell from the point of danger. The time required is inappreciable to the unaided senses, but it does, nevertheless, require a measurable interval of time to initiate and complete the process, as scientists have amply demonstrated by means of instruments of precision. It is, therefore, a process involving in its every step the exercise of intelligence and the employment of mechanism. It follows, a priori, that every cell in the body is endowed with intelligence, and this is precisely what all biological science tells us is true. Beginning with the lowest form of animal life, the humblest sighted, every living cell is endowed with a wonderful intelligence. There is, in fact, no line to be drawn between life and mind. That is to say, every living organism is a mind organism, from the monera, crawling upon the bed of the ocean, to the most highly differentiated cell in the cerebral cortex of man. Volumes have been written to demonstrate that psychological phenomena begin among the very lowest class of beings. They are met with in every form of life, from the simplest cellule to the most complicated organism. It is they that are the essential phenomena of life, inherent in all protoplasm. It is, in fact, an axiom of science that the lowest unicellular organism is endowed with the potentialities of manhood. I have remarked that each living cell is endowed with a wonderful intelligence. This is emphatically true, whether it is a unicellular organism or a constituent element of a multicellular organism. Its wonderful character consists not so much in the amount of intelligence possessed by each individual cell as it does in the quality of that intelligence. That is to say, each cell is endowed with an instinctive or intuitive knowledge of all that is essential to the preservation of its own life, the conservation of its energies, and the perpetuation of its species. In other words, it is endowed with an intuitive knowledge of the laws of its own being, which knowledge is proportioned to its stage of development and adapted to its environment. Thus, the unicellular organism is endowed, antecedently to and independently of reason, experience, or instruction, with a knowledge of the ways and means of obtaining nourishment. A mass of unorganized protoplasm, it projects portions of itself, pseudopodia, and thus performs the act of locomotion in search of food. When food is found, it is enveloped in the mass of protoplasm, digested, and assimilated. It has the power of choice, for it rejects that which is unwholesome, retaining only that which is nourishing. It has memory, as is shown by the fact that, having once encountered danger, it will afterwards avoid it when presented under similar circumstances, Mobius, or, having found food in one locality, it will afterwards seek it in the same direction, Gates. In fact, memory is one of the most elementary of psychological facts, Binet. It is susceptible to the emotions of surprise and fear, as is clearly shown by Binet's experiments with infusoria. It has feeling, for it reacts to peripheral stimuli, Haeckel. It adapts means to ends, near and remote, as is shown by Verworn's experiments with the difflugia. And finally, it reproduces itself by fission or segmentation. Binet, in his preface to the American edition of his great work on the psychic life of microorganisms, concludes a summary of the psychological properties of the lower orders of unicellular organisms in the words following. We shall not regard it as strange, perhaps, to find so complete a psychology in the history of the lower organisms, when we call to mind that, agreeably to the ideas of evolution now accepted, a higher animal is nothing more than a colony of protozoans. Every one of the cells composing such an animal has retained its primitive properties, giving them a higher degree of perfection by division of labor and by selection. The epithelial cells that secrete the nails and the hair are organisms perfected with reference to the secretion of protective parts. Similarly, the cells of the brain are organisms that have been perfected with reference to psychical attributes. The salient point to be observed here is that, so far as the physical sciences reveal the structure of man, he is composed wholly of confederated cells, each one of which has been developed and perfected with special reference to its place in the organism and the function assigned to it. Nor must it be forgotten that each individual cell is a mind organism, and that it is endowed with an intelligence commensurate with the duties it has to perform. Now, the one specific duty which each cell has to perform, under normal conditions, is to do its part toward the preservation of the life, health, and well-being of the confederated organism. Under normal conditions, that is, when no disturbing influences are at work, this task is performed easily and without friction, that is to say, in the absence of disease or traumatic disturbances. Each cell is in perfect health and automatically performs its specific function without disturbing its neighbors. But it has other duties to perform in which its intelligence is more pronouncedly in evidence. In case of disease or accident, it is charged with the duty of repairing the organism and restoring normal conditions, and this it does with an intelligence and energy that savors of creative power. No one needs to be told with what promptitude and energy and intelligence nature sets to work to heal a wound or unite a fractured bone, under favoring conditions, mental and physical. No surgeon pretends to be able to do more than establish those conditions and let nature do the rest, and every intelligent surgeon or physician will tell us that nature does its work of healing through the cooperative efforts of millions of intelligent entities, known to science as cells. Nor will any intelligent physician or surgeon or biologist gainsay the proposition that these mind organisms are governed, controlled, and directed in their work by a central intelligence resident within the organism. Scientists may differ as to the proper terminology by which the central intelligence should be designated, but no one denies its existence or its power to control its millions of subordinates. Thus, it has been called the subconscious mind, the unconscious mind, the secondary self, the subliminal consciousness, the communal soul, the secondary personality, etc. the various terms employed being governed largely by the point of view from which the subject is treated. I have designated it as the subjective mind, for reasons which have already been set forth. Philosophers may differ in opinion as to its origin and its ultimate destiny, and biologists may not be agreed as to just what it is, that is to say, whether it is the sum of all the intelligences of which the body is composed, or whether it is an independent entity capable of surviving the dissolution of the confederacy which it controls. None of these questions, however, are at issue in this discussion, for the one salient fact upon which all who are acquainted with the propaedeutics of experimental psychology are agreed is that it exists, that it is an intelligence, and that it controls the functions of the confederated cells of the physical organisms of all sentient creatures. Even Haeckel, the great materialist, who apparently knows nothing of the new psychology, in discussing the third stage of phyletic psychogenesis, has this to say of what he calls the tissue soul: this tissue soul is the higher psychological function which gives physiological individuality to the compound multicellular organism as a true cell commonwealth. It controls all the separate cell souls of the social cells, the mutually dependent citizens which constitute the community. This he holds to be true alike of plants and animals. It is, however, a work of supererogation to dwell upon the obvious fact that a confederation of intelligences, organized for a specific purpose, must act in subordination to some central power or authority. Such a power is as much a biological necessity as an executive officer is a political necessity to a state or nation. In point of fact, the cell commonwealth is more nearly analogous to an irresponsible despotism than to any other form of human government, for the central power not only controls the organism as a unit, but it controls each group of cells, organ, and each individual cell in the whole organism. This is also a biological necessity, for there can be no legislative authority to share the power or the responsibility. That it is true is evidenced by the fact that the central power is in possession of the means of reaching not only each group of cells, but each individual cell in the whole organism. This subject, however, will be discussed when we come to point out the mechanism by which this is rendered possible. In the meantime, I submit that I have already shown that the physical organism is especially adapted to the reception of mental influences, for each particular part of it is a mind organism, every function of which is controlled by an organized intelligence. The influence exercised by the controlling intelligence is, therefore, a mental influence, pure and simple, for, in the nature of things, it can be no other.